guys? Welcome to another episode of Cuda Education. Today, we are talking about depth stencil. And as you guys know, this is our application here. We're still on Compute N Body. We're talking particles and particles basically making this fireworks show, if you will. But very colorful, very nice. A bunch of particles that are showing on the screen. And it has the GPU working. In this case, I'm just running on my Intel graphics card just because. And a very nice situation, right? So this is all that's going on. But what we want to focus on today is this thing called depth stencil, right? And basically, what it is it's testing for depth and updating depth values and all of that stuff. So depth stencil deals with testing for distance from the camera or our point of interest, and deciding whether we're going to show or not show stuff, right? For this particular example, by default, right, the depth stencil test is turned off. Everything is turned off, right? And we want that because we want everything to be blended together, everything to be rendered, and have a little bit of like transparency, halo, combination, all of that stuff. So we're not, if this stuff is in front here, we're not just gonna disregard everything going on behind it, because um we want a blend, we want to see things come together, all of that good stuff. Okay, so we turn off depth stencil, or depth testing, and all of that good stuff, right? We turn it off. Okay. um and we could look at this function. This is an all-purpose function used for, so we have this function here that is used for all of the examples that we have for Vulkan. If we go to definition, we'll see that we have pipeline depth stencil state create info. We have a depth test enable, depth write enable, and then the depth compare operation. Okay. For our case, we turned it all off, and we have the nice animation that we've seen. Okay. Now let us just turn it on and see what happens. Okay. So we're going to turn these on. We're also going to, um, for the compare, we also have to change that. And then when we run it, we will see that we get a different outcome. Okay, so now the animation doesn't look as nice. Um, we don't really get nice particles as we had before. Um, we get this blotchiness, and actually we could see that each one of these so-called particles is actually a block. Okay, so visually we don't see the visually we don't see the nice particles anymore. The blending is a little bit rough because the depth test is on now, so things are blocking each other, and it just doesn't look as nice. If we turn it back off, we see we get our nice animation. Okay, so we get our nice animation now, and we have our nice particles and everything, right? Even when we zoom in, we can see that there's a level of um, just niceness to the whole presentation. If we turn it back on, we get our thing, and let's zoom in. So we see that you know, these particles actually have blocks around them, right? And that's sort of how it's rendered. So the depth uh the depth test is it's basically saying, okay, if we have a particle in front of the camera, if we have a particle in front of the camera, we're not going to render the stuff behind it, really, right? We're sort of going to block out everything behind it. um, Notice that there's kind of a square surrounding each of the particles, but one square sort of blocks what happens behind it. That's what the depth test is if you have a particle that's in front of the camera, everything else behind it generally is supposed to be discarded, right? Um, and whatever is in front just basically takes over. Now the depth right, which is the second parameter, that's the depth value. So when you have a particle that's in front of the camera, we let's say you had this, and we say, okay, for this guy, what's in front of the camera, we're going to record that depth, and everything behind this, because this is the closest thing to the camera, everything behind it we're going to discard, because it's not closer than the value that we have, right? So that's what the depth right is. It records the closest object, and it says anything behind that object, anything farther away from that object, we are going to discard. Um, so there is like a right operation that happens here. Okay. And that's pretty much the depth test. Now there is another aspect to this conversation that I want to just highlight. I don't want to get too involved with it, but we're just gonna do it, the small pieces at a time. There is also, let's go back to baseline. So we're gonna go back to baseline, which is this, right? This is baseline, right? And we have our particles and things like that. Right. So there is also another thing called blending. Okay. So right now blending is true because blending gives us our nice presentation that we have here, right? So it blends nice and everything looks cool and calm and collected and all of that stuff, right? But if we turn the blend off, right? If we turn the blend off, what happens now is that we get this, right? And this is a version of like turning off the depth stencil, but notice that we're not really blending anymore, right? And really what's happening is that these are all points, right? These are all points as far as the application is concerned. These are all points. But what gives us sort of the nice particle effect is because we have blending and because we're not depth testing. So when we don't have depth testing and when we turn on blending, these blocks right here turn into nice little particles, right? Or points, they turn into nice little particles, right? So it's not as aesthetically pleasing as before because we don't have blending enabled. Now, if we turn back on blending, now we get our nice presentation, right? We get our nice presentation, right? And the squares are kind of blended off and all of that. Maybe it has something to do with the background color. Um, we get a nice visual effect, right? um, so I did want to get into what these blocks are. So Right. So the particles are actually right. The particles are actually just points that are really blocks. So white looks blocky square now. Your particles are rendered as point sprites. Each particle is a point expanded into a square in rasterization, and the fragment shaders uses GL point chord plus a texture to make them look soft, round. Okay. Um, uh, I want to. Well, first of all, let's just make sure I'm back to baseline. Okay, I'm back to baseline. What if I just take out the whole? Oh, okay. It won't run if I if I take out the if I take out the fragment shader, it won't run. But what gives us our nice presentation is the fact that the fragment shader is doing a lot of the work, right? So the fragment shader is doing a lot of the work to make these points, not look so not look like points but look like actual particles. Okay, that's because of this fragment shader, the GL point chord. Your particles are rendered as point sprites, and the fragment shader uses GL point chord plus a texture to make them look round and soft. Okay, when you enable depth writes, the very first fragments that pass will write depth for that pixel area, and after that, later particles behind fail the depth test. You stop getting the additive layering that makes them glow soft. You're left with fewer layers contributing. The square sprite footprint becomes obvious. Okay, so the beauty of the effect is strongly tied to many blended layers, right? And that's where the blending, we could see where the blending comes in. Um, all right, so just as a test that I just thought of, I want to change. So right now we have our wonderful application, and we could see that the particles, you know, they have this nice kind of hue to them or whatever. And it's hiding the block, right? Because we have blending, we have the fragment shader doing its thing, and it makes it look really nice, right? But I want to know the full story, right? So what I want to do is I want to change the background color of the application. So I want to change the background color. So instead of it being black, I want to change it to a different color to see if we actually still see the blocks. Because right now, there's probably still a block associated with these things, or maybe not, because even when you put them in front of this, you know, you don't see a block around them. But I want to see if I change the clear color, the background color to white. If I change the background color to white, does that I don't see anything. I don't see anything. That's not gonna work. All right, let's try a different color. All right. Um. All right, well, there you have red, guys. It did work. Let's try this guy. All right. Um, all right. So the other thing that I wanted to discuss here is the fact that um, these points here, these points, they're points. They're not solid. These particles, they're points. They're not solid uh, meshes. Okay, so um, for particle clouds and things of that nature, you don't want a depth test and you don't want a depth right? For particle clouds and things of that nature. For transparent meshes, so you have a mesh but it's sort of transparent, you want a depth test, but you don't want a depth right. So you want to be able to know one thing in front of the other, but you're not gonna do a depth right where you're trying to discard and update values and things like that. Um, for things behind that object. For a solid mesh now, you do want a depth test and you do want a depth right. Okay. And for UI overlays and things like that, user interface. So for example, um, this is a user interface overlay. You're not going to do a depth test and you're not going to do a depth right on it. It's just going to stick on top of the application and give you the information that you want, regardless of what's going on the application, right? um, but yeah, guys, this is just, we're going through the motions of figuring out all that's happening as it relates to the depth stencil. So we kind of have a better idea of what the depth stencil is. Officially, when you Google this, if you Google this and look at the Vulkan spec, it says structure specifying parameters of a newly created pipeline depth stencil state, right? And these are all these are actually just some of the parameters that you could change, for the pipeline depth stencil state. Okay, and let us get some context. Where is this function actually called? It is part of the prepare graphics function, and it is part of actually creating the pipeline that we use to render the application. So if we continue down this logic, we'll see that here, the very last statement, we do a vk create, lowercase vk create graphics pipelines, and we compress all of the information that we have up here, including the depth stencil state, all of that stuff, depth stencil state, we compress all of that stuff into this one call, lowercase vk create graphics pipelines. And we know that anytime we see a lower vk function in Vulkan, we know that it's really, 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 really important. Okay, so I encourage you guys to look at this spec. You could just Google this part right here and look at the spec. online. I can't show you on the video. And see what it has to say. There's a lot of options and a lot of things that can happen. Again, Vulkan is a low level graphics API, so it gives you control and options to do a lot of things. And the burden of that is a lot of code, but the blessing is you have control over everything, and things can look really good, and also can perform really fast because you are being explicit in how you want things done. And you could get performance optimizations as a result. Anyway, guys, that's it for this video. Tutorial number one: install the Vulkan SDK on a Windows based machine with a Vulkan capable GPU. Um, it has now come to my attention that basically with the new generation of computers that are on sale today, that a lot of the integrated graphics cards are able to run Vulkan. So if you have a fairly recent machine that you bought, you probably can run Vulkan on your integrated Intel GPU. But do some research before you actually attempt to do it, just so you don't waste your time and you don't buy the wrong computer. So make sure you have a Vulkan capable GPU. That's usually NVIDIA, AMD, Intel GPU, discrete GPUs. That's fairly modern. Um, if you want to run the ray tracing stuff, this is not a ray tracing example, but if you want to run the ray tracing examples, um, you have to make sure you have an RTX card for NVIDIA. I don't know about AMD and Intel. And actually, I don't even know about the integrated graphics card. The newer integrated graphics cards, are they able to run ray tracing? I don't know. The other thing that I wanted, right, so tutorial number one is installing the Vulkan SDK on a Windows based machine. And then you have tutorial number 13, which is installing all of these examples. So you see all these examples here? This is all the examples that you'll be able to run. Again, if you want to be able to run the ray tracing stuff, you have to make sure that your graphics card is ray tracing capable. There's a ray tracing extension associated with Vulkan, and only those cards who have the ability to run the ray tracing extension, you will be able to actually um, run it and see these examples. This is Cuda Education, guys. Thank you for watching. Have a great day.